In this video, we're going to look at Newton's second law of motion. You're going to need a piece of paper to write on and a pen to write with. So Sir Isaac Newton proposed his laws of motion in 1687. Newton's laws of motion are fundamental principles in classical physics that describe the relationship between the motion of objects and the forces acting upon them. Newton's second law of motion, sometimes referred to as the law of acceleration, relates the motion of an object to the net force acting on it. It states that the acceleration of an object is directly proportional to the net force applied to it and inversely proportional to its mass. We often represent Newton's second law as an equation, as you can see on the screen now, where force is equal to mass times acceleration. The similar equation for this is that F is equal to m times A. Remember that force is measured in newtons, mass is measured in kilograms, and acceleration is measured in meters per second squared. We're now going to apply his law to a question. The question asks us to calculate the force exerted by a Paralympic wheelchair athlete as they accelerate at 2.5 meters per second squared. The mass of the athlete and their wheelchair is 94 kilograms. With all questions like this, the first thing we need to do is to be able to highlight what we know in the question. So you can see you've got 2.5 meters per second squared, that's acceleration. And we've also got 94 kilograms, which tells us their mass. We're then going to write down what we know. So I'm going to say that mass M is equal to 94 kilograms. Acceleration A is equal to 2.5 meters per second squared. Please will you be able to work through this calculation with me? The next step is to write down the equation that we know. So in this case, we've got that force is equal to mass times acceleration. We're then going to put the numbers in as they appear in the equation. So I'm going to put 94 under mass and 2.5 under my acceleration. I'm then going to write the rest of the equation. So force is equal to 94 times 2.5. We then put this into our calculator, and that will give us an answer. So if you put that into your calculator, you get that force is equal to 235. Now, the last part of this question is to make sure that we have the units. So force, remember, is measured in newtons, so I can put newtons next to that bit there. I'm just going to run through and mark my work. So if this was an exam question, I get 1 mark for putting the numbers into the equation, I get 1 mark for the answer, and 1 mark for the unit, achieving a score of 3 marks after the 3 that were available. We're going to move on and then now apply our knowledge to answering some questions by yourselves. So on the screen now you can see 3 questions. I'd like you to have a go answering these questions in the same way that I showed you in the previous example. You might want to pause the video now so you can complete the questions, and then when you finish them, you can unpause the video and I will go through the answers with you. So I would like you to pause the video now. Okay, so hopefully you've had a chance to go through these questions. Let's run through them together now. So the first thing you do remember is you highlight what you know in the question. So I've got 22 kilograms, and I've also got in this one 15 meters per second squared. You're writing down what we know. So A is going to equal 15 meters per second squared, and M equals 22 kilograms. We then write out the equation. F equals M times A. Force is mass times acceleration. And then put the numbers in. So we're going to have 22 times 15, and F is equal to the answer. If you put that into your calculator, you should get an answer of 330 newtons. Just to run through the marks, please, you get 1 mark for putting the numbers into the equation, 1 mark for the answer, and 1 mark for the correct unit. We're going to go through the same process again for this question 2. So you get the idea that the average mass is 1,600 kilograms. We get that the acceleration is 3 meters per second squared. And we'll go through and put this into the equation. So we write the equation first, that force is equal to mass times acceleration. We put the numbers in, 1,600 multiplied by 3. And if you put that into your calculator, you get 4,800 newtons. Again, to mark this, 1 mark for putting the numbers into equation, 1 mark for the correct answer, which is 4,800, and 1 mark for your unit, which is newtons. Please remember to mark your work and give yourself a score out of 3 for each question. On to the final question on this slide then. We're going to underline what we know again. So we get 160 kilograms is what our mass is equal to. We find our acceleration is 1.5 meters per second squared. Then going to write out the equation that we know. So force is mass times acceleration. We put the numbers in. 160 multiplied by 1.5. And if you put that into your calculator, you're going to come up with an answer, which in this case is 240 newtons. To run through this, see instead of the marks, we get a mark for putting our numbers into the equation, a mark for the answer, and a mark for our units. So please can you give yourself a score out of 9 for those questions there. So not all questions are going to allow you to put the numbers straight in and work out the answer without having to do some rearrangement. So we're now going to go for a worked example in a question where you're going to have to rearrange the formula. So it's the same process that we've done before. We're going to go and underline what we know in the question. So in the first case, we've got 66 newtons, that's our force. So force is equal to 66 newtons. We've got a mass of 0.2 kilograms. We're going to write that down as well, 0.2 kilograms. So as before, the first thing we do is once we've found out what we know, we're going to write down the equation. So you get that force is equal to mass times acceleration. We're going to put the numbers in. So this time we've been given 66 newtons as our force. Our mass is 0.2 kilograms, and that's going to be multiplied by our acceleration. So now we're going to have to change the equation and rearrange it in order to solve our question. So we're trying to find A. We can see on this side of the equation we've got a times, which means to bring the 0.2 to the other side of the equation, we're going to have to divide. So we're going to have 66 over 0.2 is equal to our acceleration, which means our acceleration is going to equal, just put those numbers in the calculator. So the answer comes out to be 330. I remember now that we need to put in our units, which are meters per second squared. Let's run through how we get the marks for this question. So here we get a mark for putting the numbers into the equation. Sometimes, depending on whereabouts in the paper this falls, you get an extra mark here for the rearrangement. You get a mark for the answer and a mark for the correct unit. And that's how we're going to award the marks for all the questions that involve a rearrangement today. So these are worth 4 marks. Okay, we're going to move on to the next slide, and you're going to be able to have a go at doing the questions yourself. So on the screen now, there are 3 questions for you to try. They all involve a rearrangement of the equation. I'd like you to pause the video now while you attempt to do the questions, and then once you've completed them, can you unpause the video and I'll go through the answers with you. So can you pause the video now, please? Okay, so hopefully you managed to complete the questions. I'm going to run through the answers. In the first case, we go through and underline what we know. So you get here that mass is equal to 0.42. We've also got that force is equal to 15 newtons. So you've got 15 newtons and mass being 0.42 kilograms. We're then going to put the numbers into the equation. So first step, write out the equation, that F is equal to m times A. Force is mass times acceleration. We then get 15 equals 0.42 times A. Rearranging that, we're going to have to take the times to the other side, so we get 15 over 0.42 equals 8. I'm finding it quite hard to fit this in the screen at the moment, but we're going to come down here and get that A is equal to, put the 15 over 0.42 into your calculator, we get an answer of 35.7 meters per second squared. We can go through and give ourselves the marks for this question. 1 mark for putting the numbers into the equation, 1 mark for the arrangement, 1 mark for the answer, 1 mark for the unit. It was 35.7142857 on my calculator, but I just rounded that up to 3 significant figures to get 35.7. On to question 5, we're going to follow the same process as we did before. So the first step is to find what we know in the question. So we've got 80 kilograms, that's my mass. And we've got a force here of 784. Using the equation again, the F force is mass times acceleration. We can then put the numbers in. So we get 784 equals 80 times A. Need to do the rearrangement, so we've got a times on this side. To take it to the other side, we have to do a divide. So we get 784 over 80 equals A. So A will equal, let's put that into our calculator. A is equal to 9.8 meters per second squared. Can we go through and mark that again? So we get the marks putting the numbers into the equation, a mark for the arrangement, a mark for 9.8, and a mark for meters per second squared. We're just now going to move on to the final question. So going through the process again, first part is to highlight what we know. So we've got here, this time we've got the acceleration given to us. So A is 30 meters per second squared. And we've got our force, F, is equals 12.5. 12.5 newtons. So then we go through a process that we've been doing all the time, that force equals mass times acceleration. So we write down the equation. We then put in the numbers. So we've got 12.5 equals our m this time times by 30. Then we need to rearrange it to find m. So again, we've got a times on this side, which means to move the 30 to the other side, we're going to have to divide. So we get 12.5 over 30 equals m. And we can then put those numbers into our calculator to find the value of m. So doing 12.5 over 30, we find that mass is equal to 0.416 recurring. So I'm going to round that up to 0.42. And I remember my units, which are kilograms. Going through to award the marks, we're going to get a mark for putting the numbers into the equation, a mark for the correct rearrangement, a mark for the answer, and then a mark for the unit. So you should have 3 questions there, each out of 4 marks. Can you give yourself a score out of 12 for this slide, please? Now, depending on time, hopefully you have got time, you can complete the Rally Coach questions that I've assigned you here. You can work through those on your own pace. Once they've been completed, if you listen to the final part of the video, I'll just quickly run through the answers to these questions with you. So you may want to pause the video now while you complete the Rally Coach, and then we'll go through the answers once you've completed them. So please pause the video now. So hopefully you've finished those questions, that you've unpaused the video. We're just going to run through the answers to those now. Okay, so the answer on the screen here, if you prefer, rather than listening to me, you could always stop the video there and just mark your work as we go through. I'm just going to go through and show you where the answers are. I'm going to do that in green this time because I've written the answer in red. So the first bit in the first question, you get a mark here for putting the numbers into the equation, and a mark for the answer, and you were given the unit there, so you don't get a mark this time. So it's worth 2. On part B, you've done the same thing again, 68 times 10, 1 mark for putting the numbers in, 1 mark for getting the correct answer. On the subsequent questions, the units weren't given, so you're going to get 3 marks this time, a mark for putting the question in, 15 times 3, a mark for the 45 being the correct answer, and a mark for the unit, which is newtons. Again, you're going to do 1 times 24 next, that's a mark. You get an answer for 24, and an answer for the correct unit, which is newtons. The third row of questions, again, you were given a unit this time, so you don't get a mark for that one. But you get a mark here for putting the numbers into the equation, a mark for the correct rearrangement, and a mark for the correct answer, which was 7.5. In B, you get a mark for putting the numbers into the equation, so 680 is equal to 34 times A. A mark for rearranging it by doing 680 divided by 34. A mark for the correct answer, which is 20, but you're given the unit there, so that's only out of 3. The final row of questions here, you get a mark for putting the numbers into the equation, so 1,000 equals 0.25 times acceleration. Rearrange it, so doing 1,000 over 0.25. And this time you get a mark for the answer, 4,000 meters, 4,000, and you get a mark for the unit, which is meters per second squared. The final one, you get a mark here for putting the numbers into the equation, a mark for the correct rearrangement, which is 200 over 2.4, a mark for the answer of 83.3, and then a mark for the correct unit, which is meters per second squared. So you get 2 marks here, 3 marks there, 3 marks here, and 4 marks there, allowing you to get an overall score of out of 12. So can you use yourself a score out of 12 for that worksheet, please? I hope you found this video useful. Thank you very much for listening, and I look forward to working with you again in the future. Thank you and goodbye.